All right. Class? Yes. Okay, that's not bad. Pretty good. So I know everyone's going to be paying attention right here. 100% attention, not on their phone because that would make me salty. So state the degree of each vertex in the graph below. Now, what is the degree supposed to be? Y'all got notes in front of you. The degree of the vertex. Go ahead.
Wait, give me 1 second.
Any guess is better than nothing. -4?
Wait, what? Oh, yeah, 4.
It's 4.
Yeah.
So you're saying that's 4? How'd you get 4? I'm not saying you're wrong. I'm just saying how'd you get 4?
Because the 4 into A.
4 lines. Vertices. Yes, there. It's called a balance. So perfect. Yes, he got the right answer. You had the right explanation. Good job. Teamwork. So yes, there's 4 lines going into A. 1, 2, 3, 4. All right. What do you got for B?
4.
C.
4, 3.
D.
3.
E. Yes. No. Maybe. Now, we got the degree of each one now, right? That's all it asks for. Fill it in. Yes? Good. Next one says, consider the graph below. Is a Euler path or Euler circuit shown? Can someone tell me the difference in between a path and a circuit? Go ahead. I don't like that last part. I don't like the last part. Yeah, you use it all, but I don't like that last part of it. Euler path, you don't have to end at the same place. You don't have to end it. Yeah. Yes, different place. A Euler circuit, you start and end at the same place. Is that what you said? I just messed it up? Okay, my bad. I'm sorry. Good job. You were right again. Prove me wrong. Anyway, yes. Circuit, we have to start and end at the same path. I do not have to. So, let's see if it is a Euler path or a Euler circuit. So, start here, go 1, 2, 3, 4, 5, 6, 7. That one's going to be a path because it doesn't start at this first one over here, right? This is a Euler path. There you go. Euler path does not start and end at the same place. All right, you ready to move on? No? You know, you guys were already supposed to have this done because this was your I-Day assignment. That one was due yesterday too. But some people...
Why do you have porn?
Listen, there's a long, serious explanation to go along with this just to lead up to a very bad joke.
Can I hear it?
It's a corny joke.
Is that the whole?
Yeah.
Good one.
My kid, they had a canned food drive at his school, and he left it here this morning. So he's going to take it tomorrow. All right, let's keep going. 3. Would a city street department want its snowplow operators to follow a Euler circuit or a Hamilton circuit? Now, we have to think about it. What's the difference in between Euler and Hamilton? Who? Which one? Hamilton, you don't have to use all the edges.
And you
Is
agree?
that correct? Like you just have to go from vertices to vertices?
Yep.
You don't have to
And Euler,
Euler is all the way around.
yes. So Euler, you use all the roads, right?
Yeah.
And in Hamilton, you use all the vertices. So the analogy that I gave you guys for a Euler is we're going trick-or-treating, right?
Yeah.
And if you're going trick-or-treating, you're going to cover every street, right? Yeah, trick-or-treating, you're going through all the streets. You want to make sure you get all the streets taken care of because that's where you get all that candy. A Hamilton is pizza delivery. You only care about going to every house and then going back to the start to go pick up more pizzas, right? Yes? Okay, that's how it works. So that's the difference. Which one of these would the snowplow need to use? Euler, because it's going to clean all the streets, right? There you go. What is the fewest number of edges that are needed to be added to Eulerize a graph? How do I know if this graph is going to be a Euler circuit or not? Go ahead.
The dots, so they're called vertices, right?
Yeah, vertices.
They all have to have an even number.
Very good. Even number. Perfect. They have to be even numbers. So let's go through and list it to see which ones are even and which ones are not. So right here we have, let me see, 3, 2, 3, 3, 3, 3, 3, 2. All right. To Eulerize, what do we do when we Eulerize?
Make it even.
Make it even by doing what? Adding lines. So where do you think I should add some lines?
Because if you did need an A and B uneven for D, then you have to add no lines.
Then be A to B and B to C.
No,
You're saying go C to D? Is that what I heard?
A to B.
How about that? All you have to do is add lines connecting the ones that have 3, right? Those are the ones. So now by adding a line here, this is now 4. This is 4. This is 4. This is 4, 4, and 4. So what is the minimum amount of lines to add? 3. Just have to add 3 lines, right? 1, 2, 3. The only time that we would actually have more than that is if I would probably have something that would be like when I added a line, it would make it an even number to an odd, and then I'd have to do it again to make that new one to be even again. All right, we good? Okay, let's keep going. Which of the graphs have a Euler circuit? So, do the same thing that we just got done doing. All right, to figure out if it's Euler circuit or not, I have to do what?
See if they're even.
Yeah, do the same thing that we just did. Count them up, right? Count up the vertices, and for it to be a Euler, every single vertex has to have what?
Even.
Even. An even valence. Even number of roads going in. So, by taking your pencil and writing that number there, that would be a good way to visually see each one if you can or cannot. So, 2, 3, 3, 4, 4, and 2, and 4. 2, 2, 4, 4, 2, 4. All right. Is my first diagram a Euler circuit? No, because it's got odd vertices, right? So that one's a no. So option A, nope. Option B, let's look at it. Is the second one Euler? Yes, it is. So that means it's not going to be this, and it's not going to be this, because that would be if both of them could Euler. Now, what are we doing right here on B? It says the circuit is... Now you got to try and figure out the circuit. What's the path? Start from A. You got to figure out the path. That's what you're doing right now. You're figuring out the path right now. Not staring at me awkwardly. Figure out your path. What's the path? Start at A. How can I cover every single line, every single road, and come back to A? Yes, that's what you gotta do. What's that next? You did? Okay. All right, Lashka says she has an answer. So starting at A.
Can you A, B, C, D?
Hold on. A to what?
A, B, C, D, E, F, D, B.
Hold on. From F, go where?
D,
D, delta,
E,
boy,
D, F,
F,
A.
A. Good job. You covered all roads. So we said this is A, B. You said C.
C, D, E, F, D, B, F, A.
There's the path. And that's what it is looking for. For your answer, that's what you're going to show. Jess? Good. Alrighty. Which path name below describes a Hamiltonian circuit? Now, Hamiltonian, what do we say Hamiltonian does? Every vertices, not every side, right? Okay, and what if it's a circuit, it has to... I almost heard what you said. Go ahead, say it. Okay, so yeah, Hamiltonian, I use every vertex, and then I go back to the beginning. Pizza delivery. Got to go pick up more pizzas. So let's see which one of these is going to work. I know definitely this one and this one don't work. Why do I know that those two definitely don't work? They don't go back to A, do they? Or they don't go back to the start. They start at B but don't go back to B. Start at C, doesn't go back to C. All right, let's see. This is A to B to C to D to B, then to A. Yeah, that's not a good one. Next one, AB, A to B, C, D, A. There we go. So the answer has to be D. Hey, Jahir. Not implying that you're playing with your phone during this time right now, but if you're staring down and laughing like that, it's kind of odd. No, seriously, you're like sitting there smiling and laughing at something, but from here it looks odd because from the front of the classroom, looking at you in the back, looking straight down, laughing at something. Yeah, it looks kind of weird. You're just enjoying your test review that much?
Yeah.
Good job. All right. So. Yeah.
Yeah, I was looking at my phone.
Yeah, I know. Okay. So, all right, this next one. For a graph below, what is the cost of the Hamilton circuit attained by the nearest neighbor? Now, if I was going to do nearest neighbor and starting at A, what do I have to consider if I'm doing nearest neighbor? The price, the cheapest price, right? Cheapest route. Kind of like Hotline. Is that or what Travelocity? Is it? I don't know. What are Orbits? I don't even know what is the like travel site that's supposed to go by cheapest routes? Tarago, Kayak. I don't know. All of them, right? There's like a million of them. You know what's actually sad? It's cheaper if you just go straight to the company and buy it from them.
Really?
Yeah, it's cheaper to just say, all right, go to Southwest. They have better deals than that other thing, but still. All right. So where am I going to go first? B. Go to B. All right, nearest, where do I go? C. Where's next? Where'd you say? E? You said E?
Back to E.
Back to where? Oh, you can't go there because we already covered it, right? So you don't deliver to someone's house twice. You don't go back if you don't have more pizzas for them, right? Yeah. This one is going to go to D. That's the nearest neighbor without, messing up our thing. And then the last one's going to be. So we had 60, 10, 30, 40, and 80.
220.
So our cost for using Hotline or Travelocity or whatever it is, Orbits. Now, we could go through and try and do the optimization where we go through and cancel out all the ones that are the largest and try and avoid those and make sure we used all the smallest on that. We could have done that. But, you know what? It asks for a nearest neighbor, so we just start with the smallest and just go from there. So 220. All right. You people right now, since a lot of people never even did this like they were supposed to yesterday, fill in your matrix right now, please. Fill in the matrix. Good job, Morpheus. Too ready there? Like a Matrix joke. I wasn't gonna call you Neo. All right, hopefully everyone actually has it by now. Said hopefully. Some people are still working on it. Give you a couple more seconds for people that are trying to take a nap. But heaven forbid, no one would take a nap during a test review. Just like no one would be playing on their phone during that test review either, right? Let's see what we have. A 0, 1. Good job. All right, now someone give me B all the way across. What is it? Because that's an E right there. It's kind of hard to see. Yeah. All right, go ahead. You guys agree with that one?
Yes.
You guys agree there?
Yeah.
Those are C. Yep. All right, go ahead. Goes to D, goes to A, goes to E. Yep. Good job. Should be pretty easy, right? All right, next thing. Draw a graph that represents this matrix. So all you have to do is go through and fill in. Now, serious question. Is this a digraph? Is it directed or undirected? Why undirected? Perfect, that's it. That's it. So, diagonals, and look at these. 3 to 3, 0, 0, 0, 2, 0, 0, 1. I'm sorry, 2, 1, 1, 1, 2, 2. All the diagonals are the same, so it is reflexive across the diagonal. So that means that this is going to be undirected. So I don't put arrows. No arrows, because it can go both ways. So yeah, this one's no arrows. So that's key when you're actually drawing this out, if it's arrows or not arrows. Let's see. Let me see. A to B is 3. 1, 2, 3. And A to D is 2. B to A is 3. I already got that. B to D is 1. C to C is 1. And C to D is 2. C to D is 2. And D to A is 2. D to B is 1. D to C is 2. D to D is 0. There you go. So it should look something like this. But a lot better since you guys have better drawing than me. Next one. 9. Is this one going to be directed or undirected?
Directed.
It is directed because it doesn't, it's not reflexive across this. So if you draw this right here, This right here tells you those are not the same. So that means that this is this is going one directional. This is going one directional. Okay, one directional, so make sure you add the arrows. So A to B is 1, A to C is 1, B to D is 1. Got to make sure I'm actually marking these off because I messed it up earlier. B to E is 1. Next one is C to D is 1. D to A is 1. D to D is 1. D to E is 1. Make sure you have all your arrows on there. Anyone questions here? Yes, no, maybe? Now, we're going to do this, and we're going to do it the same way we did it on our homework. I'm not going to make you try to do this in the calculator because that's more complicated to do it in the calculator. So what we are going to do is we're going to make a diagram for this and use that diagram to answer the next couple of questions. How many points should I have? 5. And how many steps is this one? This is one step because it doesn't have a 2 or a 3 or anything else. This is just one step, right? So let's take a look. So I am going to start labeling them. A, B, C, D, and E. So to do this, we're going to go through, fill this in, then we're going to make a 2-step, then we're going to do another one that's 3-step. So let's see. Is this one right here going to be directional? It is directional, right? Because it doesn't actually match. So let me see. A to B gives me 1. A to E is 2. B to B is 1. C to A is 1. C to D is 1. D to C is 1. D to E is 1. And that's it, right? Now from here, we're going to do our 2-step, which we have to use 2 roads for this to count. We have to use 2 roads for this to count. So I'm going to go down to the bottom, and I'm going to make a 2-step. So please draw your little matrix there for your 2-step. and then we're going to fill it out, but I'm not going to go up and down. I want you guys to actually fill it out as we go. So you're going to fill it out for me. All right, let's start it off. The first one's going to be, can I go from A to A in 2 steps? That one's 0, right? A to B in 2 steps. A to C in 2 steps. No. A to D in 2 steps. Nope. A to E in 2 steps. Nope. All right. We're going down the next one. So B to A. Does B actually leave B? No, it doesn't leave B, does it? So I can't get 2 steps off of that. So B is going to be zeros all the way across, right? Okay, good. Now let's look at C. Can I go from C to A in 2 steps? No, just 1 step. Can't get there in 2. C to B in 2 steps. Yes, so that's going to be a 1. Let me try this. What did we say? C to B. Next one's going to be C to C. Yes, because I go to D and then come back. C to D in 2 steps? No. C to E in 2 steps? Yes, because I can go down here. That's 1, right? I can go here. And can't I also go here? So what does that tell me? That's going to be 2. Because there's 2 different ways to go that one. Right? There we go. D to A in 2 steps. There's one pathway for that, so that's 1. D to B in 2 steps. No. 3 steps, but not 2 steps. D to C in 2 steps. No, only 1 step. D to D in 2 steps. Yes, D to D. Because I can go to C and then back. D to E in 2 steps. Nope. And let's go with E's. Is E going to go to anything? Why? Nothing leaves, right? Everything goes to E. E doesn't go to anywhere. All right. So there's your 2 step there. So let's go through, and you guys are going to help me with this. So what do we have across the top? Fabio?
All zeros.
Huh?
All zeros. These all zeros. C is 0, 1, 1, 0, 2.
2?
Yeah.
Okay.
1, 0, 0, 1, 0. That's all zeros.
All right, thank you. Now the question it's asking, how many 2-step paths are there altogether?
6.
So what do we have to do? Add them all up. I got 2, 4, 5, 6. There we go. Next one is, how many 2-step paths are there only from A to E? It's only asking for just one of the paths, for A to E. What do we get for one A to E? 0. That was 0 for A to E. Let's look right here. So A to E was 0. And that's all we have to do to pick up that answer. Next one is going to be a 3-step. So 3-step, watch this. We're going to go through this and we're going to make another matrix for a 3-step. Let's go here. There you go. Alright, so you guys are going to fill in the matrix as I go, right? Alright. So now this is 3 steps. I have to use 3 steps and I cannot reuse a road. So let's see. A to A in 3 steps. Okay. A to B in 3 steps. A to C in 3 steps. I can't go to C from A. Because I would go to E, right? But nothing leaves E. And I could also go to B, but B doesn't leave B. So that one's going to be a 0 also. A to D. 0, right? Okay, good. Now A to E. 0. I can go directly there, but I can't go using 3 roads. Now, let's go B. B to A in 3 steps. 0. Now, does B to actually go to anything? No, it doesn't leave. So I could actually just go through and mark all those out, right? Next one is C to A in 3 steps.
Yes.
How do we do that?
Oh, no. You can't go C to D, and then
C to
D to
D,
C, and then C to A.
So you're saying we go from C to D.
And then back to C, and then to A.
Yeah. Using 3 roads, I have 3 separate roads just for that, right? So that one's going to be a 1. So let me do this. C to B.
1? Yes. C to A, and then to B, and then B again. Oh, no, just 1.
I'm not using any of them over again.
I guess.
I'm not using anything more than once. I use all the same. I use them. They're all there. So I should have 1 right there. Which was that? C to B? All right. All right. C to C. 0, because I can't get anything there, right? Next one is going to be C to D. 0. C to E.
Yes.
It's going to be 3 steps.
No.
Nope. Now D. D to A in 3 steps. No, because it's 2 steps, not 3. D to B.
Yes.
Yes, it is. It is 3 steps. So it'd be 1, 2, 3. Next one is going to be D to C. 0. D to D. Nope. I can do 2, but not 3. D to E.
1.
Let's see. So 1, 2, 3.
Wait, so there's 2.
So there's 2.
Because we have 2 separate lines for this one, right? because there's two lines going from A to E, right? So my other one, I can go here, right? This way. Same here, but then right here, we take a different road at the end.
There's another one, right?
Hold on, let me back it up. Okay, now say it. So we got one already, right?
We got two.
Oh, hold on. It was D, C, A, E, right? But that, because we would use this one right here, right?
Yes.
Okay, so what was another one?
D. Wait. Yeah, D, C, back to D, C. D. Then E.
Hey, that one does work. Okay, so that's D, C, D, E. All different roads though, right?
Yeah.
All different roads, so it's a different pathway. All right, and there was another one here, right?
So it's D.
Because there's two different roads on A to E. So that means that one's going to be a 3. That one's going to be a 3. Good job. You know what? I didn't catch all those last time I did this. So I have to go change up my YouTube video because that's wrong.
You're proud of us.
Yeah, I am. Because you guys find stuff that I miss out on. And so that one was supposed to be a 3. I'm going to...
And then E is all 0, right?
Yes. E is going to be all zeros because E doesn't go anywhere. There we go. So let's fill in our matrix. So what do we have?
Zeros.
0 all the way across?
Yeah. And for B, 2. 1, 1, and then all zeros. 0, 1, 0, 0, 3, and all zeros.
There we go. Now, the question it's asking this time, how many 3-step paths are there altogether? Let me see. 1, 2, 3, 4, 5, 6. Now, how many 3-step paths from D to C? D to C? 0. Is that easy now? Was it just a bit of work because I had to do the matrix and the diagram?
Yeah.
But once we did the diagram, it made everything easier. So, here's a hint. When you do it again on the test, make your diagram. Especially if you have to try and turn a 1-step into 2-step into 3-step. And that's what we did right here. All right. Now, this next one, question 14, says, suppose you are on a camping trip and want to explore all 6 scenic locations at Grills National Park. Below is a table giving distances between all locations. Create a weighted graph detailing the above table. Find the shortest path from your campsite at Ford Canyon to each destination and back. So, I'm going to do this. I'm going to start this off by going, this is going to be A, B, C, D, E, and F. A, B, C, D, E, and F. Start by doing that. Because otherwise, when you make the diagram for this, you're going to have to write out all those names, right? Do you want to do that? Say no.
No.
So what am I going to be looking for when you do this?
Letters.
Yeah, the letters. Label your letters for these because it's going to make your life a whole lot easier. Yeah? Good. Now, we're going to have to make a weighted graph. So, next page, weighted graph. We have A, B, C, D, E, and F. if you paid attention to my instructions, where do I start?
E.
Why B? Because that's where it says to start. It says start at Ford Canyon. And what did we list Ford Canyon as? B was Ford Canyon, wasn't it? That's what I need you guys to pay attention to, especially if you're not starting on your very first one. So when we do this, you're going to have pathways for all of these. So it's going to look like this. There we go. All the pathways are going to look something like this, but now I'm going to put in the values. And I'm going to do this right here. I'm going to change up the color on this just so we can see what goes where, because some of these ones are kind of hard to decipher, especially since it is kind of a mess here. So I'm going to do them in purple because I got to put the weights in there, and that's where I'm going to put the weights right at each side right here. So A to C is going to be on this piece. F to B is going to be on this piece right here. B to D is going to be on this piece right here. We had trouble with this earlier because a lot of people didn't put their numbers where it's supposed to go. So I'm trying to make a way that you guys could see it a little bit better. And so this is going to go F to D. All right. So I'm going to fill in the values. So A to B is 1. B to C is 4. C to D is 3. D to 6. This is going to be 7 and 9, and then let me see, A to C is 5. Next one is F to B is 8. The next one is A to E is 2. Let's see, next one is E to C or C to E is 5. D to F is 1. B to D is 3. So I'm pretty sure you guys could actually make yours better than mine, but I'm just trying to list everything as I go. And people are just playing on their phone because, you know, it's almost like this is on the test and you might need to pass this test, otherwise you don't graduate. You know, you don't get credit for this semester because you wanted to watch that TikTok video. kind of sad. All right, and I'm missing a couple. What am I missing? I'll do this one in black. So right here. So F to C or C to F is 4. Next one is A to D is 7. And next one is E to B. B 4. All right, I know it kind of looks like a mess, but we have everything listed, and I did different colors so we can see the different pathways. Now, we need to start at B, which is going to be right here. What roads do I want to avoid? A to, definitely A to F, right? Definitely A to F. So I'm going to gray that one here. So I want to avoid that one there. Which ones do I really, really want to use? A, B. I'm going to start A to B, right? Okay, so that one's an important one I want to use. So I am going to, what's a good color on this one now? Blue? Okay, so A to B is one I want to use. And then A to E is another one I want to use, right? What's the next one I want to try and use? No, can't go back. Because remember, we're doing a scenic path. So I don't want to actually see people texting, but it's all right. You can take this class in summer school. So we want to actually cover, most likely, CD and BD. Okay, so let's, okay, so I want to cover this one here, right? Or B to D. So let's see. So if I'm going to try and avoid values like that, so I can go from E to D. Watch this. I'm going to go E to D. Now, D to F is a good one too, right?
Yeah.
D to F because that's only one. So if I'm counting them up as I go, I have 1, 2, what else? 6. And then D to F is 1. And then what else do I go? F to C. Now F to C is how much? 4. And on my way back, did I cover everything else? Yeah, look, I covered everything else, so now I can head back. Which my answer is now going to be 4. So, I want to take the smallest route since this is going to be a hike. I don't want to, if these are all in kilometers, it's going to be a long hike. Let's see, how many do we get here? So we got 8, 9, 15, 16, 17, 18. So miles or kilometers, whichever. And this is going to be your answer to this being the shortest route. It's not? You got shorter? How'd you get shorter?
I went to B to A.
Oh, hold on. B to A. So let me, I'll do black. Actually, no, brown's a good ugly color. No, let's do green. Okay, you said B to A.
A to E.
A to E.
E to C.
E to C.
E to F.
C to
C to F,
F
F to B or D,
F to D.
and then D to D.
All right, looks like everything is covered. So let's count it up. So that's going to be, I'm going to change colors because 1, 2, oh, I didn't color. 1, 2, 5, 4, 1, 3. Let's see what we got. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So let me see. We get 8, 12, 13, 16. Wow. Good job. That's better than mine. Good job. Because when I did this one earlier, I came out with 19, but I let the students actually do it. So good job. So by doing it that way, you did the same thing we did. You just did it in a different way, right? So you avoided the AF, and you avoided BF, and you avoided FE, which are all the longest ones, and you avoided AD. So that's good. Good job. All right, so going back to the question. Question says, find the shortest path from your campsite to Ford County for each destination back. So, right here, create a weighted graph. Right here, find the shortest path, and the shortest path is going to be what you just had right there, which was 18. 16, sorry, 16. All right, okay. So, good job. Don't forget, like, share, and subscribe. Hit that notification button, and follow me at my merch store. Buy my stuff.